In this tutorial, we'll start our look into horizontal expansions and compressions, and we'll start by looking at the points. For example, if we expand this graph horizontally by a factor of 2, we multiply the x value of each point by a factor of 2. If we take this point here, 1, 1, and expand by a factor of 2, then the y value stays the same, and the x value is multiplied by 2, and we expand it in the horizontal direction. The point 1, 1 gets expanded horizontally to become 2, 1. And we can do this same horizontal expansion for all of the points in the graph, allowing us to see our new horizontally expanded graph. If instead we compress the same graph horizontally by a factor of 2, then we compress each point horizontally by multiplying the x value by 1/2. If we take this point here, 1, 1, we'll leave the y value the same, that is 1, while the x value is multiplied by 1/2, and we compress in the horizontal direction. The point 1, 1 gets compressed horizontally to become 1/2, 1. And we can do this same horizontal compression to all of the points in this graph, allowing us to see our new horizontally compressed graph. Let's look at some related examples. Example 1. Given f in terms of x below, describe the new g in terms of x, as shown. And in this case, we're given a general function f in terms of x, and it looks like some form of square root function, but we don't know the details, so we'll just work with the graph and points as shown. It looks like a horizontal compression happened here. That is, it was squeezed together horizontally towards the y-axis. Let's pick a point that we can analyze. This one looks good. -6, 0. Its corresponding point on our new graph here, well, that's -2, 0. So the y value stays the same, that is 0, but the x value goes from -6 to -2. It's clearly not a horizontal translation, that is, the entire graph didn't shift equally, so we conclude that this shift is due to a horizontal compression. And we have to multiply -6 by 1/3 would get us to our new value, -2. So we're compressing by a factor of 3. Thus, we know that we need to put a 3 in our equation right here, in with our x. Let's look at this point here, 0, 4. And the corresponding point in our new graph is, well, it's also 0, 4. And let's see if that agrees with our conclusion around a horizontal compression by a factor of 3. The y value stays the same, so 4 stays 4. Check. And the x value has to be multiplied by 1/3. Now 0 times 1/3 is 0. So yeah, that checks out as well. So far so good. Just like the x-intercepts stay the same in a vertical expansion or compression, the y-intercepts stay the same in a horizontal expansion or compression. Now, though we'd like a third point to confirm our answer, we'll have to settle for a 2-point conclusion here. Example 2. Given f in terms of x as below, sketch f in terms of -1/2 x. Now in this case, we're given a general function f in terms of x. It looks a lot like a cubic function, but we don't know the details, so we'll just work with our graph or points as shown. Now, first we see that we have a negative in with the x. Now, had this negative been in with the y, or in front of the function f, it would have indicated a vertical reflection. But in with the x like this, we know that it has to be a horizontal reflection. Thus, we'll note to self, let's make sure that a result has a horizontal reflection. And we'll carry on. We note that along with the negative, we also have a 1/2 in with the x, indicating a horizontal expansion by 2. And we can combine our horizontal expansion and reflection by saying that we have a horizontal expansion by a factor of -2. So let's pick some points from our original graph to work with. Here we have a local maximum, and this will work well. Now, if we have a horizontal expansion by -2, then the x value is going to be multiplied by -2. So our corresponding point would be -1 times -2 is +2. And then the same y value, that is 1, and we can plot our point right here. First point down. Next, let's look at this point here on the origin. And again, the y value stays the same, and the x value is expanded by -2. So we multiply the x value by -2, or 0 times -2 is 0. So this point stays the exact same, right at the origin. And that's expected, remembering that in a horizontal expansion or compression, the y-intercepts stay the same. And we have one more point that we'll plot here. How about this local minimum? 1, -1. Again, the y value stays the same, and we expand the x value. 1 times -2 is -2. So our new point is -2, -1, right here. And that's probably enough to make a rough sketch here. So we have our transformation. And we can double check that our horizontal reflection has been taken care of. Seeing the reflection around the y-axis, and we know we're good.